In Chem 1A, we will only deal with the combustion of hydrocarbons. This is a reaction that occurs when a molecule made of hydrogen, carbon, and usually oxygen reacts with oxygen gas to produce water, carbon dioxide, and energy in the form of light and heat. The formula of the reaction will always look like this, and the molecule can have many different atomic ratios involving those three elements. It's also important to note that we write O2 instead of just O, because oxygen is a diatomic atom, which means that when it's by itself and not part of a larger molecule, it always exists as 2. Here's a mnemonic that you can use to remember the rest of the diatomic elements. Now we can solve our problem. We're told that a substance combusts and produces carbon dioxide and water. We already know the form the reaction will look like. We can also decipher that all the carbon and carbon dioxide must have come from this substance, because there's no other source of carbon in the reaction. The same thing goes for the hydrogen in water. The oxygen found in carbon dioxide and water, on the other hand, can have either come from the substance or the oxygen gas that was used in combustion, so it isn't as immediately helpful. The first step we can do to figure out the molecular formula of the substance is to figure out how many grams of pure carbon and pure hydrogen the substance had. I recommend first converting your quantities from milligrams to grams, just because it'll be easier to deal with later on. Now we know how many grams of carbon dioxide we have. Carbon dioxide has 1 carbon and 2 oxygens, so we know the molar mass of carbon dioxide is around 44.01 grams per mole. We'll use this knowledge to find how much pure carbon was in the carbon dioxide we have. We'll put the molar mass of carbon dioxide on the bottom and the molar mass of carbon on top. Repeat these steps to find out how many grams of hydrogen were in the grams of water we produced. Then we know how much hydrogen must have been in the original substance. To find the molar mass of water, keep in mind that water has 2 hydrogens and 1 oxygen. When writing your molecular ratio, you need to remember that water has 2 hydrogen atoms, so you have to account for this when you're writing the amount of hydrogen in water. It's not just 1.008. Now we know how many grams of carbon and how many grams of hydrogen were in the original substance. Since we were given its weight, we can also figure out how many grams had to have come from oxygen. In other words, whatever leftover mass we have must have come from oxygen, because there's no other element in the molecule. You can find this by simply subtracting from the original weight we were given. This means that we have 0.00763 grams of oxygen. Now, the next step is to convert all the values to moles using molar mass. An easy way to know if you're going to multiply or divide by the molar mass is to just make sure the units cancel out. You can find the molar mass of each element by looking at your periodic table, and you should round to around 3 or 4 sig figs. Since we know the moles of each atom in the molecule, we can now find the molecular formula. You're going to use this ratio. This is something you should memorize for Gen Chem. You're going to divide by the smallest amount of moles. So in our case, oxygen is the smallest amount of moles. So we're going to divide carbon and hydrogen by oxygen. The units cancel out and we're left with numerical values. Since we divided by oxygen, it'll always be 1. All molecules have whole number ratios. Since we had 1.5 H's, we need to multiply everything by 2. If we had 0.33 H's, for example, we could multiply everything by 3. Finally, we found the simplest number ratio of this molecule. This is called an empirical formula. It's essential to understand what the question is asking you. In this case, we found the empirical formula, the simplest atomic ratio of the molecule, but the question asked for the molecular formula. This means that the true version of the molecule is going to exist in this form, but multiplied by a whole number. And we can figure out what this number is by looking at the information given to us at the beginning. If 0.25 moles weighs 41.5 grams, the molecular mass is 166 grams per mole. This is exactly 2 times as much as our calculated molecular mass. So, to find the molecular formula, we're just going to multiply everything by 2. If it was exactly 3 times, we would multiply everything by 3. And that's how we found our answer.